5.7b. Let's continue on page 416 and do some of the Pythagorean equation problems. What we're given here is not an A, B, and a C. We're given some lengths here on A. In fact, the hypotenuse, the longest side, is C, and they're saying this is 3 and this is 4. This 90, let's erase that, we don't need that. We only need to know that there's a little triangle in one of the angles of the triangle. Every triangle that the Pythagorean works in fact, only triangles work where there's a little square here showing this is a 90-degree angle. It's the only time you can use the Pythagorean theorem. So I'll leave it up there. And A and B are basically two of the short sides of the triangle. Doesn't matter if this is A or this is A or this is B or this is B. The longest one is always C. The other ones doesn't really matter. So that being the case, if we follow the formula, let's make this one A since it's right here. So it's going to be written, we're going to replace the A with a 4 and we're going to replace the B with a 3. And that equals C squared. Alright, so this is actually 16 plus 9 equals C squared. And when we add these, we get 25 equals C squared. Alright, that doesn't really help us a whole lot. 25 equals C squared. Because we're looking for C. We're looking for the length of this hypotenuse. So we're given that. We're looking for that. C squared is not the length of that. C is the length of that. So we've got to get rid of that C squared. Alright, if you remember, whenever we had 3x equals 12, how did we get rid of the 3? We did the opposite. We divided. When we have x plus 3 equals 6, how did we get rid of the 3? We did the opposite. We subtracted. It's the same way dealing with exponents. Remember I said the opposite, or the inverse, I guess is a better word, for square is the square root. So 25, the square root of 25 is what number times itself is going to give me 25, and it was 5, because 5 times 5 equals 25. It's the same thing. It's the inverse. So what we're going to do is we're going to do the same thing here. In order to get rid of the 2 here, we are going to take the square root of both sides. We're going to do this, and we're going to do this to both sides. When we take the square root of a C squared, it's just like when we were dividing, if it said multiply, and we divided, it got rid of it. It's going to happen the same way here. When you take the square root of something that has an exponent of 2, it gets rid of not only the 2, but the sign. So everything disappears except what was inside the sign. Now C equals the square root of 25. Okay, so what number times itself gives me 25? 5. So my C is no longer a C, it's a 5. Alright, let's do another one. Some new stuff there for most of you. So let's do it one more time now that you kind of have an idea of what's happening. We're going to use C again, and we're going to, this is a crummy looking triangle, and a 7. Put our Pythagorean on here. Okay, our A is 7. Our B is 5. Again, it doesn't matter which one is which. And our C squared is what we're looking for. So 49 plus 25 equals C squared. And add those up and we get 74. Trying to get rid of this exponent here, so we're going to take the square root of that, and we get square root of 74 equals C. And if you plug that into your calculator, you're going to get a number like 8.6. And that will be what my C equals. So that's Pythagorean. If you look at example 11, gives you more of an application of using Pythagorean. They've got that ladder leaned up against the house there, and they made it into a triangle with the ladder being up the side of the house 6 feet, and the distance from the base of the ladder to the house is 8, and they're wanting to find out how long the ladder is. So same thing that we really did with the triangles in example 10. So problem set 5.7, 417. They're just giving you some radicals to figure out. Notice A says simplify each of the following without using a calculator. So 9 through 28 they're asking you to do without the use of a calculator. Well, it shouldn't be too bad. Let's do 22. 6 square root of 64 plus 11 square root of 100. So we're going to take the square root of each of these first. 6 times 8 plus 11 times 10. Do our multiplication first. 48 plus 110. And that gives us 158, because now we can combine them because the radical's off. When we were in this position, we've got a radical here and a radical here. They're not the same, can't combine them. But down here, once the radical sign came off, we could combine them, and life is good again. Alright, so that's 1 through 28. Number 29 to 32 is just asking you to determine if those problems are true or false. For example, 29, this is a good concept to get down. Alright, this says, they're asking if this is true. Square root of 4 plus the square root of 9 equals the square root of 4 plus 9. Well, what is the square root of 4? What is the square root of 9? Does that equal, what's 4 plus 9? 13. Okay, so they're saying, or asking you, if 5 equals the square root of 13. Well, if you take your handy-dandy calculator and you take the square root of 13, you'll find that the answer to that is 3 point something. So these two are not equal to each other. And they're saying that to get you to recognize that you can't split up radicals into this, and you can't take radicals that are split up and make here. Remember what I said. If these are not the same, you cannot combine those. You can't bring them together. So don't even think about doing that, because you'll get the wrong answer and life will really stink. Alright. Let's hop to the next page here, 418. Whole bunch of Pythagorean. All you're doing is finding the hypotenuse. You're finding C. They're giving you A and B, so you're just plugging the numbers in and coming up with the answer. Just real quickly, let's do 38. It's giving you a side of 6 and the other side of 6. So A squared plus B squared equals C squared. So 36 plus 36 equals C squared. 72 equals C squared. Square root of 72 equals C. We should take the square root of both sides to get rid of all this stuff here. And we get the square root of 72 equals C. Plug in your calculator, square root of 72, and you end up with a number somewhere between 8 and 9. So 8 point something. Alright, so that's 5.7 problem set. We're done.